Modeling with linear functions. All right, so here's your state standards that we're going to be talking about today and your success criteria. You need to be able to write equations of linear functions. You need to be able to compare linear equations to solve real-world problems, and you need to be able to determine a line of best fit. All right, so I know most of you guys have not had Algebra 1 for 2 years, but all of this information was covered in Algebra 1. So this whole chapter is basically a review of Algebra 1, and even a good part of the next chapter is as well. So we will go through this kind of quickly because it is a review. So your vocabulary that you need to know: line of fit. When the data of a scatter plot shows an approximately linear relationship, you can model the data with a line of fit. The line of best fit is the line that best models a set of data and lies as close as possible to all the data points. The correlation coefficient, denoted by R, and you'll be able to use this in your calculator as well. You'll see the R, that's your correlation coefficient, is a number that ranges from -1 to 1. When R is near 1, there is a strong positive correlation and the points lie close to the line with a positive slope. When R is near or close to -1, there is a strong negative correlation and the points lie close to a line with a negative slope. As R gets closer to 0, the correlation becomes weaker. So if you have a number that's close to 0, that means there's probably very little or no correlation between the points and the equation you're trying to write for a line for those points. All right, key ideas. Write an equation of a line. Given slope and y-intercept, remember your slope is m, your y-intercept is b. Slope-intercept form is y equals mx plus b. You should remember that. You did that both in 8th grade and Algebra 1. Given the slope m and a point x1, y1, you can use point slope form. Y minus y1 equals m times x minus x1. This is point slope form. We don't use it as much, but you should commit that to memory. You should know that as well. And given points x1, y1, and x2, y2, you can find the slope, okay? Finding a line of fit. There are 4 steps to doing that. Make a scatter plot. Draw the line that most closely appears to the data points. Choose 2 points on the line and estimate the coordinates. And write an equation of the line. Example 1, writing a linear equation from a graph. The graph shows the distant asteroid 2019 GC6 travels in x seconds. Write an equation of the line and interpret the slope. The asteroid came within 136,000 miles of Earth in April 2019. About how long does it take the asteroid to travel that distance? All right, so the first thing it says is to write an equation of the line and interpret the slope. All right, so if we look at the graph, we have time in seconds and we have distance in miles. We're given this point here as 6 and 21, and we know we have a point here of 0, 0. So the first thing we can do is identify the slope, because if we write an equation in slope-intercept form, y equals mx plus b, we can see that the y-intercept is at 0. So we already know the y-intercept, but we do need the slope. So let's find the slope. So your slope formula, remember, that's y2 minus y1 over x2 minus x1. So this is from Algebra 1, but you are supposed to still remember it. So a little review won't hurt. All right, so you're going to have, this is my x and my y from my first point, and this is an x and a y from my second point. So you've got 0, 0 as a point and 621. So I'm going to do 21 minus 0 over 6 minus 0, and that's 21 over 6. So 21 over 6, 6 goes into 18 3 times and 3 left over. So that's 3.5 or 3.5. All right, now that we have M, and we know that the y-intercept is 0, we can say y equals 3.5x plus 0. And if it's plus 0, we really don't have to have that as part of the equation because 0 doesn't change anything. All right, so what does that mean? So the slope indicates that the asteroid travels 3.5 miles per second, because you can see again, this is in time in seconds. All right, so the next part says the asteroid came within 136,000 miles of Earth in April 2019. About how long does it take the asteroid to travel that distance? All right, so we can see that distance in miles, that's your y value. It's on the y-axis. So we're going to take this 136,000 and substitute that in for y. So 136,000 equals 3.5x, and we can solve by dividing by 3.5. So x is about 38,857. So we're going to have 38,000 857. All right, and that's in seconds. All right, so we don't really determine how long in seconds. We usually talk about it in minutes or miles or something more practical. So let's say, let's calculate a little bit here. All right, there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. All right, so we've already worked with units. So there are about 3,600 seconds in an hour. All right, so if we have 38,857, let's divide that by 3,600 and 10.8. All right, so x is about 10.8. And we can round that. We can say, we can round that up to the closest hour, which would be 11 hours. So we can say it takes the asteroid about 11 hours to travel this 136,000 miles. That's still pretty quick, though. I mean, if you think about how fast that is, if you drove for 11 hours, you're definitely not going to travel 136,000 miles. So that asteroid is traveling very, very fast. But that's all for example 1. All right, example 2, comparing linear equations. 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost in dollars for different numbers of students at Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort is represented by the equation Y equals 10X plus 600. So this is an equation for Sunview Resort. This is a table for Lakeside Inn. Which venue charges less per student? So the first thing we need to do is write an equation using the table for Lakeside Inn. We need an equation for both so we can see how they compare. So again, let's find the slope. All right, so I'm going to have, let's just use the first 2 points. It doesn't matter. So we're going to have 1,800 minus 1,500 over 125 minus 100. All right, so we're going to have 300 over 25. So that's what, 12? All right, so we have a slope of 12. All right, now we don't have a y-intercept, but we have all these points. So let's take one of the points and use y minus y1 equals our slope times x minus x1. So all we have to do is use point slope form, and then we can choose a point. Let's just use the first point here. So our y value is 1500. So we're going to say y minus 1500 equals 12 times x minus the x is 100 students for that point. And then we can rewrite it. So y minus 1500 equals 12x minus 1200. Add 1500. That'll put it in the same form as the other equation. Y equals 12x plus 300. All right, so that is an equation for Lakeside Inn using the table. And we have an equation for Sunview Resort, which is already given to us. And it says which venue charges less per student. So what we can do is set the two equations equal and see what x comes out to be. So right now you can see that the y-intercepts, this one, they charge a flat fee of $600. This one only charges a flat fee of $300. But this one charges $12 per student, where this one only charges $10 per student. So if we set the two equations equal, that'll allow us to see when the price is going to be the same. All right, so if I subtract 10x, that means let's subtract 300 from the other side. We're trying to solve for x. So 6 minus 3 is 300, and that's going to equal 12 minus 10 is 2x, divide by 2, x is 150. All right, so what is that 150? That's the number of students. So they're equal. The cost will be equal when it's 150. Let's graph these and see what it looks like. So I would say the one with the smaller y-intercept is going to cost less up until they intersect, and then the one with the higher y-intercept but the lower student cost will be cheaper after 150 students. So it will depend on how many students they plan on having attend prom to see which one would be the cheaper cost. All right, so 12x plus 300. Let's see, the other equation was 10x plus 600. I like to visually see things. It kind of helps. All right, so if we're not seeing anything on here, it's because my window is not big enough to see what's going on. We know that we have 150 students, and that's in our x value. So let's change our x to, let's change our x maximum to, let's say 200. And let's change our scale as well, because if we don't, it's going to look really crazy. And our y maximum, our y's go up past 2,700. So let's change our y value to 2,800. I'm just choosing a number slightly bigger than, and I'm going to make a scale of 100 for that one as well. And I make the number slightly bigger in the window because I want to see the intersection point. All right, so you can see where they cross right here. And you can see this one says the blue line is 300, so it's exactly what I was saying. This one's going to be cheaper.